In this video, we'll discuss about Levey Jennings chart and Westgard rules. So, in this video, laboratory quality control continuation, Levey Jennings chart and Westgard rules. These are the tools used for internal quality control in laboratory to monitor and evaluate the analytical process on a day-to-day basis. So, these are the tools used for internal quality control in laboratory to monitor and evaluate the analytical processes on a day-to-day basis. Specific learning object are: describe the significance of LJ charts in statistical quality control. Second one is describe Westgard rules and their importance. Third one is evaluate LJ chart for Westgard rules, violations, and most likely associated errors. So, three main objects: significance of LJ chart. Second one is Westgard rules and their importance. Then evaluate LJ chart for Westgard rule, violation, and most likely associated errors. Levey Jennings chart is also known as LJ chart. It is very useful tool in internal quality control, and it is the graphical method for displaying control result and evaluating whether a procedure in control or out of control. So it is a graphical method for displaying control result and evaluating whether a procedure is in control or out of control. Daily control values are plotted versus time. So daily control result values are plotted. Lines are drawn from point to point to understand any systematic or random errors. So here lines are drawn from point to point. Understand any systematic or random errors. The LJ chart is basically a Gaussians on its side. Gaussians on its side separated by time as a frequency. So LJ chart basically a Gaussian on its sides separated by time as a frequency. For consulting LJ chart and evaluating that laboratory or analytical process, we need important parameters, that is mean and standard deviation. So we need two important parameters, mean and standard deviation. In previous video, we have seen how to calculate mean and standard deviation, and the data points for calculation of mean and standard deviation we get by running QC, quality control sample, 20 times. We get 20 data points, and those using 20 data point we calculated mean and standard deviation. And also we have seen that how to calculate plus or minus 1 standard deviation, plus or 2 standard deviation, plus or 3 standard deviation. Mean 100, standard deviation 2. So we have already calculated plus or minus 1 standard deviation, ranges from 98 to 102. Plus 2 minus standard deviation ranges from 96 to 104. plus 3 or minus standard deviation ranges from 94 to 106, and the standard deviation is required to consult LJ chart. LJ chart can be consulted manually or already it is presentation in the automated analyzers. This LJ chart, which is considered by using mean 100 and standard deviation 2. Here you can see at the center is mean. This black color line plus or minus 1 standard deviation. That second line blue color one shows plus 2 or minus 2 standard deviation. This purple color plus 3 or minus 3 standard deviation. This LJ chart used to plot the result of control value that we process every day before analyzing our patient samples. So if the control value, that is we get within that specified range, that is we plotted in the LJ chart. So here our result we have plotted here. So we say that our result within the control or out of control, within control or out of control. So for example, on the day 1, if I get the result 104, so I have plotted here in this biochemical auto analyzer, or the graph is automatically created. So biochemistry auto analyzer, the graph is automatically created, no need to draw it manually. For example, on the second day I get value 101, then the data point here. Likewise, third day I get that value 98. The data point of control value will be here 98. So this is how the data point will be plotted against the days. We get visual display on our data point on this LJ chart. Day 1, 2, 3, this one is total samples. Now coming to Westgard rules. What are the Westgard rules and what is the importance? The Westgard rules are given by Dr. James Westgard, and they are used to detecting changes in the analytical system. Why this rule are required? Dr. Westgard has formulated this rule to decide whether an analytical runs in control or out of control. He formulates rules to decide whether an analytical runs is in control or out of control. This rule can be applied as single rules or as a group of rules, that is multiple rules. It can apply single or multiple rules. Westgard rules can be applied only if your quality control are plotted within the range of 3 standard deviation. So there are 6 important Westgard rules is there. 1 2 years, 2 2 years, 1 3 years, 4 1 years, 10x and or 4x. These are the 6 important rules. So many laboratory uses only 1 2 years, 2 2 years, 1 3 years on routine basis. What is 8 meaning by 1 2 years? 1 What is meaning by 1 2 years? Okay, this 1 represent n, 2 represent l. What is n? N number of control measurement. If you take example of 1 2 years rules, first one is number of control measurement. 2 years means limit exceed. This one is limit exceed. When one control measurement exceed 2 standard deviation, it is called as 1 2 years rules. So this is how the Westgard rules nomenclature has been done. So let's discuss important of each rules. First one is 1 2 years. Already said 1 means number of control measurement. So here number of control measurement is 1. It exceed the 2 standard deviation. Here you can see 1 control measurements. 1 control measurements exceed plus 2 standard deviation. That's why it is called as 1 2 years rules. Now what is 1 2 years rules indicate? It is just a warning signal. It is not rejection rule. And 1 2 years denote a random error or beginning of the systematic error. Now second rule is 2 2 years or 2 2 years. This way we will write. 2 means control measurement, and the second rule, this one, second 2 is standard deviation. These first two control measurement, second 2 is standard deviation. So here you can see 2 consecutive control measurement above 2 standard deviation limits. So this is 2 2 years rules. This rule is across run. Why it is called across run? Daily we have to run quality control material, that is normal quality control material and abnormal quality control material. So across run means, for example, day 4 you got one value. Day 4 you got one value which exceed plus 2 that standard deviation, and day 5 again you get that value exceed plus 2 standard deviation. So 2 value exceed 2 standard deviation. 2 value exceed 2 standard valuation. So this is 2 years rules. It across run. But let's say if you are running both normal control and abnormal control. In abnormal control you get one control measurement above this 2 standard deviation, then this is also called as 2 years run. Both normal and abnormal control material you got that value above 2 standard deviation. That's why it is called as 2 years rules. It is denoted a systematic error. Next one is 1 3 years rules. What is meaning by 1 3 years? Here you see that fifth control measurement on one data point is above 3 standard deviation. That's why it is called as 1 3 rules. It denote random error or beginning of a large systematic error. This is suddenly a rejection rule, and we have to reject our run, and we have to troubleshoot uh, process of random error or large systematic error, and we have to correct the action only the patient sample can be proceed. What is 41s? Here phone, here these four control measurement and one standard deviation. So four consecutive control point, four consecutive control point or above one standard deviation. When you are running single control sample for 4 consecutive days, you are getting result above one standard deviation, though they are below 2 standard deviation. This also rejection rule, and you get all the 4 values in the same run. It is called as 41s rules, that is within the run, and if you are running to control level. So for 2 days, if you are getting 2 data point above one standard deviation, then it is also 41s rules, and it's 41 rules across the run, and it's denote the systematic error, and definitely it rejection rules, and we have to troubleshoot for the causes of systematic error in our analytical process. Then what is 10x rules? If you are running normal control and for 10 consecutive days, if you are getting the data point within one standard deviation, it is called as within 10x rules. And if you are running two level of control for 5 consecutive days, you are getting the result beyond one standard deviation, it is called as 10x rules across. It is denote the systematic error. Then last one is R4S rules. Here you can see that there are two level of control. If one level of control is 2 standard deviation, and the second level of control is also 2 standard deviation, but the difference between both level control, that is one is positive side, another one is negative side. So if the difference between both the control level in the same run is more than equal to 4 standard deviation difference, then it is called as R4S rules. Here two levels of control material with 4 standard deviation difference between two data point. So this R4S denote a random error. Thanks for watching.